the sine of the square root of x all over the square root of x dx, can you go through the process from beginning to end in order to figure out what this integral is? Now remember, we're never going to let u equal x. Okay, that just doesn't make sense. That's just replacing all the x's with u's, and then that doesn't get us anywhere. But in this case, remember, I have a function within a function. I have the sine and I have the square root of x in there. So this is the function within a function. That is what I'm going to let equal u. But here's the mistake that kids make. Kids will let u equal rad x, they pick that out correctly, but then they're going to start writing out that it's the sine of u over u dx, and that gets us nowhere, because I still have this dx right there. Remember, I'm not just plugging in u for the square root of x wherever I see it. I need to take the derivative of this. I need to figure out what du dx is, and then use that to go through. So don't just like start shoving in u right now and suddenly I get to this right here, and this right here is, well, that's not going to get us anywhere. So don't just go ahead and see that. I need to go ahead and take a derivative and then start working things out. So do you guys remember the derivative of the square root of x? Remember, it's x to the 1/2 power. So it's going to be 1/2 x to the negative 1/2, which is 1 over 2 square root of x. So that's going to be the derivative. And where this comes in, remember, du is going to be 1 over 2 rad x dx. Now here is the important stuff. Boom. All right, but now it's just seeing it. So here's what I'm gonna do. Just like before, I am gonna rewrite this integral so the substitution is easier to see. I get the sine of rad x. And I'm gonna multiply this by 1 over 1 over rad x dx. So all I did was I took this original problem right here and I rewrote it to look like this. I just did that so hopefully you can see the substitution easier, okay? So that's what I like to do. I like to write it out. And then remember what we have here. U is going to be the rad x, okay? So that's what I got right there. I need a 1 over 2 rad x for the du. So I need the 1 over 2 rad x dx. So what I got to do is I got to throw in this 2 out here. Okay. So I'm throwing a 2 down there. Do you know what I'm throwing in front of the integral though? So if I throw a 2 down there, what am I throwing out front? Yeah, I'm not throwing out a 1/2, I'm throwing out a 2, because that is 1 over 2 on the inside, so a 2 on the outside. All right, because remember, I need that to equal 1. But now I have the 1 over 2 rad x dx. Come on, I can do it. Just coloring. There we go. Yay, coloring. So now I have that. Okay, I got the 1 over 2 rad x dx. I got the rad x. So now here is what we have. This turns into 2 integral sine of u, and this whole thing is du. So remember, it's sine of u du. So what this is going to equal, that's going to give me to the integral of sine. Remember, the integral of sine is not cosine. The derivative of sine is cosine. So the integral of sine is negative cosine of u plus c, which this will turn into negative 2 cosine square root of x plus c. That is, oh boy, that is going to be the final answer, okay? Multiplying the 2 in and then replacing the u with the square root of x. All right. So I wanted to choose this one to show you some places where kids make mistakes, okay? The first one was, remember, just because I let u equal rad x, that doesn't mean that both of these are u. So remember not to do that. And then it's also making sure that you can see the substitution. That's why I wrote this out the way I did, so you can hopefully see it a little better. Now, what's going to happen is you have choices to make depending on how you want to go ahead and solve the problem. So if I go through this next one, can I take that off screen? What time we got? All right. So I'm going to take this off screen, and I got another one where kids make simple mistakes. Okay, so if I go through something like the integral of sine of 4x cosine of 4x dx. Now, typically what kids do is they'll see this problem and they'll look at 4x and they'll be like, totally get it, u equals 4x. So then du is going to equal a 4 dx, okay, just kind of going through. So they'll throw a 4 in, they'll throw a 1/4 out, okay, that's pretty standard, it's pretty standard, and they'll get 1/4 the integral sine of u cosine of u du. Then they'll sit and stare at it. Because I have two things multiplied together, there has to be a way to find that integral. But right now, the way it's written is I don't know the integral of sine of u cosine of u. There's no function that I took the derivative of that gave me sine times cosine, okay? At least the way that it's written. So just because I have an innermost part of the function that 4x, remember, that's 95% of the time I'll use it. Here's that, falls in that 5% category where I'm not going to use the innermost part of the function. Okay, so what I got to do is remember, if I try that out, that's totally cool. Try it out. But if it doesn't work, you're going to have to scrap it. So then you're going to have to try some other things. So we're scrapping that idea. Okay, we're going to try something else to hopefully make sure it works. So if you wrote it down, just, write this below it. But since I'm not going to let u equal just 4x, I'm going to go a little bit bigger, okay? Remember, whatever I let u equal, I got to take its derivative. And hopefully that derivative will be another part of the function that can cancel out or that can be substituted. So what I'm going to do is I'm going to let u equal this whole thing. I'm going to let u equal the sine of 4x, okay? The reason I'm doing that is what's the derivative of sine of 4x? Well, the derivative of sine is cosine, and the derivative of 4x is 4. So that tells me that du is going to equal cosine of 4x times a 4 dx. Okay, so that's what I have. I'll try and write it a little bit bigger. So that's what I get. I have u, I have du, but now it's just making sure you can see it. Okay, so just because I don't want to mess up more stuff, leave a little space here, dx, okay. So remember what I have. Out of my original problem, I feel like I'm cruising. We're doing okay? Out of my original problem, u is going to be u is going to be a sine of 4x. So that is this right here, sine of 4x. Okay. I need du to be a cosine of 4x times 4. The only thing I'm missing is that 4. So I'm going to throw in the 4. I'm going to throw a 1/4 out. Boom. And now I have my cosine of 4x dx. Cosine of 4x times 4 dx. That's what I got. So now if I pay attention to the entire substitution, I have the 1/4. I have the integral sign. This whole thing is u. This whole thing is du. Okay. So that whole thing is du, and that's it. I get the integral of u du. So now this goes back to exactly what we did on Monday. We had the power rule. We have basically a polynomial here. So what this turns into then is 1/4 u to the 1 plus 1 over 1 plus 1 plus c. Okay, so that's my power rule. So that is going to give me 1/8 u squared plus c. And so that is going to be, what is that? That's going to be a 1/8. What did we say u was? Sine of 4x squared plus c. Okay. So this is my answer. Okay. Some kids write this wrong though. Some kids will drop that parenthesis and they'll write sine of 4x squared plus c. That's wrong. Don't do that. I could write it as 1/8 sine squared of 4x plus c. This is right, but this right here in the middle is wrong. So don't do that. Okay. So either write it as sine of 4x, the quantity squared, or write it as sine squared of 4x. But that's what we got to pay attention to, the small details of how these problems are written. All right. We are at the point of the day where I want you to try one. Okay. And so I'm just going to write out the problem, and in a few minutes, I'll write out an answer. And then we're going to do one more after that, because that's a doozy. That's a big one. That's a... You know, that's one for the record books. But here is the one that I think you guys can just kind of suffer through. I'm going to take the integral of e to the 1 over x squared all over x cubed dx. Boom. There we go, kids. Bum, 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 bum. So, Andrew, if you were to get that answer, I would let u equal cosine of 4x. Okay. I could do this problem if u equals cosine of 4x. du is going to be a minus sine of 4x dx, and there's a 4 right there. So I could go through the process this way. Okay. So if I were to let u equal cosine of 4x, then I would get this, then I would get a negative answer. Okay, so totally cool if you want to go that route. But I just chose sine because the derivative of sine is a positive cosine. All right, so back to it. E to the 1 over x squared over x cubed. Easy peasy. Or less so. I really don't know. But if you need a hint, I can definitely give you one. I'm just sitting here drinking my water. So, I mean, if you're sitting here wondering like, man, what should I do? I would probably let u equal 1 over x squared, because that's the innermost part of the function. I have e raised to that, so that's like the innermost part. So this, I would definitely let u, because it's e to the 1 over x squared. And the rest is if you can follow the derivative from first semester, and can you keep track of how everything is written? So you guys should be able to take the derivative of that. I'm going to write that as x to the negative 2 because it's easier to take the derivative when it's x to the negative 2. You could go through the quotient rule, low d high minus high d low over low low, but then you got to cancel out the x's and things like that. So I'm going to write it out like this. du dx is going to be a minus 2x to the negative 3, which then I get du is going to equal a negative 2 over x cubed dx, okay? And I think if I write it like that, it's a little bit easier to follow. Bum, ba, bum, bum, bum. Dun, 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 dun. Now, no, you can't do it with 1 over x because I still have the x cubed right there. So I'd have to let u equal 1 over x squared. Because here is where my substitution comes in. I'm going to write it like this. E to the 1 over x squared times 1 over x cubed dx. I just rewrote the integral so I could see the substitution better. Okay. So e to the 1 over x squared, if I multiply it through, it'd go in the numerator. So I just wrote it like this so I could see that, I mean, u is 1 over x squared. So that's right there. And then du is going to be a negative 2 over x cubed. So the only thing I'm missing is that negative 2 business. So the only thing I'm missing is I need a negative 2 right here. So if I throw in a negative 2, I throw out a negative 1/2 because that's the number 1. It doesn't change the original function. So now I get this. And that was straight from Tuesday, which I can then write like that. And that is my integral. But it's understanding what u is going to be, how to take the derivative and work with it, and then go through the process of solving it out. All right. I got one more for you kids, and we're going to call it a day because we only got 20 minutes left. So here it is. I'm going to take this off screen, and I'm going to get a whole new paper, whole new page for this. So this is it. Last one, and then you guys should get to work on some Delta math. We'll talk about this week, next week, and the future. So let's do this. There we go. There it is. All right. All right, so once you see it, it's not too bad, but now it's just the little trick that some kids miss, okay? So the trick is not what u is going to be. Remember, u is going to be the innermost part of the function. So that's the innermost part of the function, all right? I have the cube root of something. So I'm going to let u equal x minus 5. That's the innermost part. So then taking a derivative, du dx is going to equal 1. So du is going to equal a dx. Boom, 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 boom. That's what I got. All right. So that's pretty straightforward. So here's where my substitution brings me. I get x plus 4. I get the cube root of u, and I get du. If you can see that, pickles. There we go. If you can see that this right here is going to be u, okay? So I got that taken care of. Oh no. Come on, work. No. Dios mío. All right, so we're having technical difficulties. There goes notes. Hopefully they're still there. Let's go Google Drive. Let's go. Come on, Google. Google me. Google me. And bringing it back to life. Bringing it back to the page. Bringing it back. All right. Hey, got the band back together. Boom. So I got you are. Come on now. Why do you do this to me? Oh, because I don't want that. All right, so there we go. Well, we're just switching colors now. So I got u is going to be x minus 5. I got du is going to be dx. So that's what brought me down here. I got my du and I got my u. Okay, no big deal. The only thing is I have this x right here. I can't have an x right there. There's no way I can do this problem if I have x's and u's mixed. They shouldn't intermingle. So what can I replace x with? And all of you should be able to see it, hopefully. It's written there on the screen. X is going to equal, got people typing, waiting for it to come in. Dun, dun, yes! That's exactly what x should be. I know that here, u is going to equal x minus 5, so x is going to equal a u plus 5, and that is going in for x. That was supposed to be an arrow right there. So that's going in for x, okay? So what I get is I get the integral of u plus 5, okay, plus a 4 times, I'm going to write u to the 1/3, and then du. So that's what I get. I just have that substitution. Now I get everything in terms of u. I get the integral of u plus 9 times u to the 1/3 du. And this brings us straight back to Monday. When we started doing these things, working backwards, power rule, you know that I just can't take the integral the way it's written, but what I need to do is distribute that inside, and then I'm good to go. So what I get is I get the integral of u to the 4/3 plus 9u to the 1/3 du. Talk to yourself. We got fraction exponents. Make sure you're cool with it. Okay. But 1/3 plus 1 is 4/3, and boom. So now it's going through everything that we did on Monday. So this is where I speed up the process a little bit. This right here is u to the 4/3 plus 1 over a 4/3 plus 1. This right here is 9u to the 1/3 plus 1 over, 1/3 plus 1 plus c. And then 4/3 plus 1 is 7/3. So I get 3/7 u to the 7/3 plus 4/3, 3/4 times 9, 27/4. I'm just spitting out numbers now. Boom, there we go. Follow those fractions, kids. Flipping them, multiplying them. So then my final answer is 3/7. I got x minus 5 to the 7/3. 27/4. Make sure you understand where that come from. X minus 5 to the 4/3 plus c. And that's all from my original problem of this thing. Boom. And there you have it. There we go. There we go. But everything I just wrote down that you see on the screen was straight from Monday. The only thing that's new is u substitution, choosing a u, taking a derivative, substituting, integrating, rewriting it back in terms of x. So all of this is part of the process, okay? We have all of these functions that we can now take the integral of. They're all in the book. I didn't write them all down because I don't have to. They're all in the book, okay? But we are seeing examples of what to do here.